In this edition of the Executive Outlook, we are joined by Julian Wiffen, a senior leader in AI and data science who has focused his career on turning AI from theories into the practical tools for real teams. With deep experience in building Gen AI solutions, AI copilots, and data products that improve how engineers and businesses work every day, Julian's bring a very grounded view of where AI truly adds value. Welcome to the Executive Hour.
Thanks very much, Isha. Well, I'm happy to be here.
So I'm very excited to know how did it all begin and what led you to have on this role.
Quite a long time back. I studied chemistry at university, but our final year was a research year, and effectively it was a master's degree. At that time, back in the 90s, computational chemistry was a very new thing. I picked a project in the computational chemistry department, which was looking at actually genetic algorithms, working out how you could breed a solution to try and fit input variables into an output and predict things. And I was quite pleased that we were able to actually predict, basically extract the gas laws and some of the basic bits of physics, stuff that would be trivial for machine learning, but back then was fairly exciting. And that got me into this sort of AI ML space very early, and also got me hands on with a lot of data and a lot of data, working with data right from the start. Kind of out of university, then I took a very data focused job it was in management consulting, but again, there was a lot of data warehousing, a lot of heavy analytics, a little bit of machine learning there, but not much at that point. And it kind of always skirted around the edges of the career. My early career was a lot of it was straightforward BI or more of the data engineering, data analysis stuff, getting things into a warehouse, getting it ready for reporting, handling all the messy prep work that you need to do. Gradually, you started to get to do more of the hands-on data science, the actual predictive modeling and the like. I spent a period in contracting, which was exciting time for anybody in data, really. You get to do a lot of hands-on stuff. The only problem is you never really get to see the results of your work because you finish the project and then move off, and you don't really see whether actually the things you produced actually had a major impact on the business or got filed away in a dusty corner of their company internet and not used. I then spent quite a lot of years at Cisco, again, doing various very data-focused roles, a bit of stuff in business operations and actually leading some IT software teams. I ran what's called our service catalog, which was very focused on people ordering services, whether it was infrastructure, whether it was on-prem or AWS or mobile apps and like. Again, a lot went into understanding what people were using and how much they were ordering, analyzing the value of preventing over ordering. And we found some exciting stuff there that if you made it really easy for people to get stuff, they tended not to over order capacity. And that actually saved a fortune in terms of infrastructure, like not avoiding the need for $50 million to spend on a data center. We use the analogy of like, if you live next door to the supermarket, you're far less likely to buy more than you need and waste food than if it's an hour's drive away. And out of Cisco, then I ended up with Matillion. I decided a large company, the problem with a giant company is sometimes it's hard. You spend more time making the value case for the opportunity to do experimental things than it would take to do them. And I've since found that joining a startup or scale up style company, Matillion is, there's much more of a hunger to experiment and to just do and willingness to take risks. And that's so certainly I'd say that for Gen AI project, if you're prepared to be bold, joining a smaller firm and just doing stuff, sometimes you're asking for forgiveness rather than permission, can lead valuable insights and or ability to move quickly. Just doing stuff seems to be the lesson of success in this space. The saga with Matillion is that I was brought in to look at how AI could improve the product, look at how it could be relevant both in terms of us understanding how people are using it, but also how it could be used within our software. And what Matillion sells is software to help people make data business ready or analysis ready, primarily aimed at data engineers. Migrating people to a cloud data warehouse of some form has a lot of connectors, a lot of ways to get data in, and then a lot of tools to help you transform it, get it into whatever shape you want or need. And what we found with generative AI is this opens up a whole bunch of stuff for data engineering. One is just the need to start working with unstructured formats, because suddenly there's a use for text files, audio files, video files that previously would never go in a corporate data warehouse. It would all be like filed in somebody's network drive and forgotten about, unless some poor unfortunate analyst was going to be assigned to read through them all or listen to them all and take notes. But now what we found quite early on is you can use large language models to ask questions about free text or video or audio and get instruction insights from them. So again, this is quite early on in our journey. We realized that if you just ask a model to say, answer just yes or no only, you can then turn things into something very tangible that you could use for BI or reporting or operational process. Let's say I have a bunch of consumer reviews from my website. I could go through all those chunks of text and say, just answer yes or no. Does this person actually highlight an actionable defect we could fix? Are they just praising the product or moaning about it? Or are they saying this specific feature's got a problem? Is there something I want to pass to my product team to say, you should go and have a look at that? Or just yes or no, is there a new feature request in this piece of text? It's a great way to churn through large documents or large amounts of unstructured data and find the bits that are relevant to whatever question you're asking. And finally, the other parts we kind of learned out of that by that whole process of getting an LLM to make a decision and put things in a very structured, confined format. We could even get the large language models to work with the YAML format we had for the configuration of our software. So a user goes into our low-code platform, they drag and drop components, they fill in parameters. Those parameters might be, get this table from this schema and that table from a different schema, and then a component to join them, and here's the keys they join on, and here's the thing, here's another component to aggregate, and another one to filter. And all of that's stored in a proprietary YAML format. We didn't expect the LLMs to be able to touch that because it's hidden, it's never been published, it's never been shared. But it was designed to be human readable. So we ended up finding that actually you could edit it with a large language model. And that was what led us on to a kind of copilot structure and ultimately what we've launched as Maya. That's the long journey about how we got here. And obviously happy to drill more into any of those.
Thank you so much for sharing that. So you have been working from a long time in AI field.
It's certainly an exciting time to be in the field. The stuff where previously you kind of had to beg executive teams to pay attention or to let you do a POC. Now they're demanding data teams and their software teams, in some cases, just do something cool with AI. Now, a lot are better at that and more targeted, but there's certainly a lot of businesses where the very fact that it's doing something machine learning related now gets it a polish that previously scared people off.
So what was the difference in terms of technology you have seen versus then and now?
I think OpenAI and ChatGPT did us a lot of favors because they created, well, ultimately, I suspect they're going to get their money from business applications by creating a consumer product. And because it was text-based rather than number-based, it led to a far larger proportion of the world's population getting their hands on with it, just trying it and seeing some imagining potential. Right or wrong, they might be completely misunderstanding chunks of it, but they saw a glimpse of what it could do. And that actually led to kind of much wider excitement. And it took it out of the hands of the previously ML, a lot of the technology, your traditional predictive models, and even natural language processing was the realm of pure data scientists. You generally only engaged with it if you had like an advanced degree in the space, a deep understanding of maths, and an environment that was happy to let you put your head down for 2-3 weeks doing an experiment that half the company didn't understand. And what's happened with the burst of GenAI is suddenly there's a lot more excitement. People could understand that just how powerful some of these techniques are. And it's come out of the labs or the specialized units looking at vision or robot intelligence or similar into more general use. So I'd say it was the kind of democratization or the widespread publicity around the space. And I think the large language models meant that suddenly you can work with data that's in a messy input format at a level that you can actually get something useful.
Can you share some examples that where you have implemented the AI or data solutions and that has impacted the business?
I'll talk about tools. I'll come on to Maya as the assistant in a moment because that's our crown jewels kind of thing. We talk about AI in the product and AI in the pipeline. AI in the product is Maya as the assistant, not the documentation stuff that helps the user. AI in the pipeline refers to the use of large language models or generative AI to transform data, as I touched on at the beginning. By asking questions about it and getting structured outputs, you can then get it into a format that's much more easy to work with. Even if it's just, does this page of data talk about this topic? Yes or no? Okay, now I can filter my 100-page document down to the 3 pages that actually cover the topic I care about. So to give a few examples of them where we've created tools that, again, in our drag and drop environment, people could easily then use these models. And that, because we're a low-code environment, we're able to put it in the hands of people who've got domain expertise. They don't have to be Python coders. They don't have to be data scientists, but they do have to be the people who know what a good and bad answer looks like. So to run through a few examples, we built a customer support pipeline where all the support tickets that come in from our customers get run through this to start with. And that follows a process of vector search, RAG search against our knowledge base, our documentation, our known issues list, and collates up a binder of information about relevant stuff that might be relevant to the case, and then does a job at us, the large language model, to take a stab at creating a first draft email response. And that first draft email might be, here's a list of things to try. It might be, okay, we're definitely going to need to know A, B, C facts based on this. Please, can you send that back to the customer straight away? Or it could be his suggested solution. And that then went through the customer success agent, and they could either copy and paste it and send it as was, or they could edit it and send, or they could give us feedback that it was rubbish, that sort of thing. And that actually highlighted a very interesting factor, that one of the ones that was flagged as rubbish famously showed us how dependent you are on well-written docs, because the case had a question about, can you use a SharePoint connector to send an Excel file back to SharePoint? And the model had come back with an answer that said, yes, you can. The agent said, no, you couldn't. We reviewed it. And on the call, two people said, reading the doc said, yeah, the model's right. Yeah, you can do it. And two people reading the doc said, no, the model's wrong. You can't do it. Turned out you couldn't do it, but the knowledge base article was sufficiently ambiguously worded that people were confused the same way the models were confused. And it taught us that if you write stuff well for humans, it'll be useful for a large language model. But that kind of case response thing was a very good early success for us. And another couple of cool ones, we had a customer that's processing customer feedback. They're in financial services. They have to, by regulatory rules, do this every year. Very manual process, thousands of responses, thousands of person hours each time they process it. And these feedback forms are free text. And what we're able to do is work out a process, kind of 3 loops. One is go through a sample and get some topics that are coming out. Like, what are people talking about here? And then the second is to dedupe that list of topics into like a list of 20. So, okay, these are 20 tangible topic areas. And then the third pass is to go through with that list of 20, all of the surveys, and say, okay, do they mention this topic? If they do mention this topic, extract the text relevant to that topic only. And then finally, for the extracted text, give me a sentiment score. So now I've got a very measurable view of like who's talking about what, that you can tie back to what products people are buying, demographics, all the rest. But also you get separate sentiment score on each. So previously you might have given somebody a 7 out of 10 sentiment for it's mixed. They like some things, they hate others. Now I'm saying actually they've given you a 9 out of 10 for the quality of financial advice and a 3 out of 10 for the fee structure, aka in financial terms, they love the product, they just like to pay you less money for it. And that's a lot more insightful than it's kind of neutral because it averages out. Another cool one that didn't really get off the ground, but I thought it was a very interesting use case, was a medical app. The plan was you have an app on your phone, record a diary note each day with your symptoms if you're on a clinical trial or taking medication. Then we'd take the transcript, transcribe it, ask yes, no questions like, did they mention taking their medication today? Do they sound depressed or down? They mentioned loss of appetite as a symptom. And the really cool thing is, one, because it's all free, top of mind, you're not on a structured survey, you're not leading them. And you can also add new questions. So let's say halfway through that study, they realize, actually, we think a lot of people mentioned nausea here. It might be a side effect. Let's go back to the start of all the recordings and check for all the ones mentioning nausea. Or even let's go back to surveys recorded long before the start of GenAI, historical stuff 10, 20 years ago, and mine that information for valuable data. So lots of cool stuff there. That's the AI and the pipeline side. Product side is even more exciting for us. We built Maya, which puts an agentic system at the heart of our user interface. So you can type in your requirements or your questions about pipeline or what you want to do. So for example, I want to connect to this API. Here's the API documentation. Please configure a connector for me. You can drop in the URL for the connector's documentation. All you really need is a key and it'll build the connection. You can then drag and drop that. I can configure it for you. I could then give an instruction like, okay, pull all the tables from this, get that into a star schema, document what you've done, document your logic. Very short commands, quite long and complex tasks being built out. Or equally, you can use it to debug. You can use it to explain. We launched the precursor to this, Copilot, about a year and a half ago. It helped with transformations, but couldn't do the advanced stuff like all the connections. In June this year, we launched Maya, which is a more advanced version, which can do all those connections and is a lot more accurate and powerful. And it's getting a lot of excitement from our customers. We've had one big pharmaceutical company did an actual bake-off. They set 2 of their data engineers a task to build a complex pipeline of data for data transformation and extraction. One person took 10 hours manually, and the one using Maya was able to build the exact same thing in an hour. We've had other customers that have reported between 5 to 10x productivity gains conservatively, not just for doing an individual task, but for their whole team. Like literally one customer said, I was going to hire 5 extra people for my team, but now actually I've got one, and with Maya, he can do everything I need. It's really groundbreaking levels of productivity gain for the teams. That has huge impacts. We see several use cases. One is the consolidation of all sorts of legacy jobs. There's a really nice side benefit of the large language models is that they're very polyglot. They'll understand all sorts of programming languages and all sorts of formats. So you could take an Informatica job or an Ultrix job or just a big long screen of SQL and say, hey, Maya, can you translate this effectively translate it into pseudocode to say, what's this doing? And then say, now build this out within Matillion's data productivity cloud. The nice side benefit is because we're a graphical interface, you can then inspect everything that people have built, that Maya's built for you. You can see the logic step by step. You can sample along the way and check that it's doing what you you wanted it to do. And that's able to churn through huge numbers of lines of legacy code and get on top of it. The second big thing is use of GenAI is really driving a lot more demand for data. It's generating a lot more data, and people need a lot more of it to fuel the AI projects. So that's putting a whole lot more load on data engineering teams who historically have been massively overloaded and stretched anyway all the time. There isn't a data engineering team in the planet that's on top of their backlog. So being able to give them an assistant to really drive productivity is a bit of a godsend and stops them being the villain that gets blamed for the AI project failing and makes them into the heroes that make it work. And third, of course, is just traditional reporting needs, operational data needs are still huge, and helping people scale and get on top of those backlogs is a big win. So a lot of wins there. The other fun little one is just the language comprehension ability. We didn't make any plans around this at all. We almost discovered by accident that you can use them to translate because they've read all sorts of languages. They're well versed. So both for translating data in the pipeline or for working with Maya, you can put your inputs in and say, I'd like my responses in German or Arabic or Urdu, please. And the large language models do that for us. We've put no effort into localization in Matillion itself. But when you've got a chat interface that will work with you in whatever language you prefer, for a lot of customers that are used to having to struggle like translating the head to English and then work with a piece of software, this has gone down really well.
Thank you so much for sharing so many innovations that has happened within the product itself. As we are evolving in the industry, so what do you think as a Gen AI and a data engineer? How do you think the ETL pipelines and the job of the data engineers will gonna change in the next few years?
There's two strands I'd see. One, and we've touched on already, which is their job's going to involve working with unstructured data a lot more, different formats. You're going to be working with cool transcripts, videos, messy wikis, and similar. And that's, you can get that into something useful now. You can work with it. It's also just needed anyway for the other models to consume. The second strand is as you get assistants like Maya and you start to get tools like Snowflake Intelligence and the other kind of chat with your data, text to SQL generators. The thing that becomes key is well-organized context, particularly that we have the ability to store context files. Working on semantic systems to track, okay, what does this column really mean? How do these tables interact? When somebody says customers, which are the 15 tables in your data warehouse with a name that sounds like customer should it really use? In our context, we need to map and handle thousands of tables and explain to the model when somebody talks in business language, which one of those they really refer to. And doubly so, I think, as the chat with your data tools start to become prevalent, the ability for business users to request reports. Those things live or die by well-curated schemas with good contextual information. So I believe a lot of the data engineer's job is going to involve not just wrangling the data, but also making sure all the documentation's in the right shape. You've got a nice, well-curated gold layer in Databricks terms that not just a human user, but that an ML application can then connect. A lot of change, basically.
So, can you give some advice to the leaders who are just beginning their journey in the implementation of AI and what things they should be care about?
Number one, just try stuff. Just get experimental and try things. Number two, look for the boring bits. The bits that are best ideal to automate with Gen AI are the bits that are time consuming, but where you or your people don't feel like they're adding a ton of value. It's the tasks where, you might grab some poor unfortunate intern and say, you got to sit through and check all this X, Y, Z, whatever it is, and review it for a week. That's a prime task for an LLM to do. The third is work out in advance how you judge what success looks like, what good looks like. The fourth is get the people who have got the domain expertise involved in that, working out what good looks like, and involved in building the project so that they feel like they're using it to enable themselves. It's not just a threat, an external, not invented here thing. Because as they own it, they will start to see adjacencies in their job about things they can automate or ways they can optimize it. Or equally, they'll be the ones that can honestly say whether this is working or not. And you want them on side so that they give the project a fair hearing, for good or ill. Or they can say, this is really enabling me and helping me be more productive. The other useful one we just found is if you're doing a POC and it's kind of half working, but the accuracy is not quite there yet, it's not quite good enough, don't abandon it. Feel free to park it for 3 months or 6 months. The rate of advance in model quality and the context windows and the ability of models to handle things is moving so fast. We basically would have 3 or 4 different POCs on the go at one point. And if one was got to a point where it wasn't really quite doing it, okay, we'll just store that, save that off, swap our attention to one of the others, come back to the first one 6 months later, and suddenly like, oh, a newer model actually solves that problem for you. Those would be my main tips. But yeah, just try stuff, get hands-on is my main advice.
Amazing insights. I think this will be really valuable because sometimes if an initiative POC is not successful, we disheartened and we will say, okay, we don't want to do it again. If
Yeah,
it is not working, wait for some time, prepare yourself, and then restart it. So
yeah, exactly that.
thank you so much for sharing your journey, your insights on building useful AI products, rethinking of ETL from the Gen AI perspective and guiding the next generation of data and AI professionals.
Cool.
It's been pleasure having you on the executive hour.
Thanks, Isha. It was good chatting.